Hello, Damien Mears here. This is a presentation I gave about a month ago on iOS and Android and C# and Xamarin. These are a few of my favorite things. And the reason for this presentation is to share some of what makes programming in C# and .NET a joy, especially on iOS and Android. It's aimed more at people programming in Swift or Java or Kotlin, just to give an insight into this world. I pay a lot of attention to what's happening in those other programming languages, so I thought it'd be cool to just show a little bit from this side of the mirror. So I started programming on the ZX81, a Z80 machine code, if I remember correctly, followed quickly by the BBC microcomputer Model B. It was created by a company called Acorn, who went on to create the Acorn RISC machine. So that little phone you have in your pocket descended into that computer, my second computer. In the 1990s, I was programming on Microsoft Windows in C, doing a lot of Microsoft COM and DCOM, and along came something that changed the world. It was Java, and I leapt wholeheartedly into the Java world. I loved the idea of being able to write a program once and have it run anywhere. Yeah, I really was naive to think that would work, and it kind of did. I mean, often though, you wrote your program once and it looked crap everywhere. But still, what was cool about Java was the use of, obviously, of the virtual machine. And this was, from my perspective, the first time that it was kind of viable in a big programming language. At the same time as Java was coming out, Microsoft released Microsoft.NET. And it was 19 megabytes big and would take 48 minutes to download. Those were the days, 2003. At the time it came out, I saw it came out, I was kind of aware of it, but I thought it was a little bit silly compared to all the cool things you could do in Java. But I changed my mind on that, but I'll let you know why in a second. So what I'm going to do is share three things about C# that I like, that I love, that I wish were in other programming languages. So the first thing are lambdas. Now, lambdas are pretty much everywhere now, although I spent 5 years working at Evernote on Android, and a lot of the time I spent, my brain was hurting. It hurt my brain to program in Java on Android at the time because there were no lambdas. And the way you did things if you wanted to call back or pass callback code was to essentially define interfaces, and I'll look at that in a second. So if I look first of all at what Microsoft's equivalent to the way things were done in Java at the time were something called delegates. And delegates were, if I look it up, a function pointer. And I remember distinctly in those early 2000s hearing that Microsoft had function pointers in C# and thinking that that was absolutely ludicrous. Had they not learned anything about, from COM and C and C++, function pointers were evil as far as I was concerned, and I couldn't understand, or didn't want to understand why they might actually make sense. So when I programmed in Java at Evernote on Android, if I wanted to pass a reference to some code around, the first thing I would do is define an interface. Here I've called it iCallback with a particular method, in this case called callback method. The next thing I would do is define a class that took a reference to that interface as a parameter, and it could then make a callback on something that implemented that interface. So every time I wanted to reuse some code or essentially pass a reference to some code, this is what I would do. And then next I would create a class that implemented that interface, that actually had my code, and I might implement this in different ways depending on what I wanted to do. So, and then I'd implement the interface, and then finally I'd actually be able to pass a reference to the class that implemented the interface to a method, and that would call back on my code. This was so painful. I hated it as a Java programmer. I know things have changed a lot, in the newer versions of Java, and obviously Kotlin, is changing the world of Android development. But this was my reality. So in C#, if you wanted to do the same kind of things, in the very first versions, what you would do is define a delegate. So a delegate defines the shape of a method. So I've got a method here, a delegate called callback, that says it's anything that any method that takes a string as a parameter and returns an int can be passed or can be substituted for this delegate type. So I've got a method here called SumMethod that takes a delegate as a parameter, and it can then invoke the delegate. So delegate defines it is a type. It's literally a type, and it says this something that takes a string as a parameter and returns an int, in this case here. And then in order to actually make use of it, I create a method called callback implementation here, and you can see that it conforms to the delegate, and it takes a string as a parameter and it returns an integer. Then in my when I want to make use of it, I can pass a reference to this method as a parameter. So that is the function pointer, if you like. It's a pointer to that function callback implementation. And I can pass it because the callback implementation conforms to that delegate type. It's still kind of clunky, and things change. Obviously, things evolved, and I guess that's one of the things that that was different between Java and C#. C# had the benefit of a benevolent dictator, Anders Hallsberg, who had a very strong vision and a strong perspective, and so things moved a lot faster in the C# world than they did in the Java world. So very quickly, instead of actually having to define that delegate, so that method, that implementation method, I can essentially inline it here. So this is creating a delegate behind the scenes. It's taking a parameter called message, and it's returning the message, the length of the message. So that's essentially doing the job of the delegate. I still have the delegate at the top up here. So this is conforming to the delegate. It takes a string as a parameter and returns an integer. But it's a simpler way of doing things. Now, what about on the called code there? So that delegate type. It's still kind of clunky, and one thing I could do is, instead of defining it for one particular type, so a string as a parameter as an integer as a result, I could create myself a generic callback that takes an integer as a parameter and returns, so it takes some kind of a parameter, t1 as a parameter, and returns a t result. So the second parameter here is the return type. So I can say, okay, it takes a t1 as the parameter and returns a t result. And so I can make use of that then when I'm defining my method. I can say, okay, it takes a string as a parameter and returns an integer. So that's the generic callback, or the delegate, that's passed in, and away I go. And so that's it's nicer because I don't have to define loads of different delegate types. One takes a string as a parameter and returns an int. One takes an integer parameter and returns a string, and so on. I can just declare this generic type, and so life is easier. I just define a instantiation of the generic type here. Now, it was such a good idea to do this that Microsoft built that concept into the language. So there's a func type, and there's loads and loads of these different funcs that are defined. One takes one parameter, two parameters. Actually, func, because it's returning something, returns an integer, so it's just it's always two or more. So that's now built into the .NET framework. So it makes makes life a lot easier. So func is defined that returns a value, and there's also an action. So that makes life simpler. So if we look at the code before, it's like this, and afterwards it's become much shorter and much more simple to understand. So that was kind of how things evolved in the C# programming language over time, to the point now where it's much more concise. So the second thing about C# that I love is LINQ, language integrated query. So let's say I have an enumerable of strings. So this is an interface here. It's an enumerable of strings, and I'm assigning it to a concrete implementation type, which is a list of strings 1, 2, 3, and I print out each value in the enumeration, and so I get all my different elements 0, 1, 2, 3 printed out. Let's say I wanted to filter that. What I could do is define myself a method called where. So here I have a method called where that takes an enumerable of strings as a parameter, and it takes a filter as a parameter, and then applies that filter. So the method is called where, it takes the enumerable of strings as a parameter, takes a filter that takes a string as a parameter and returns a Boolean, true or false, and then for each element in the enumerable, it applies the filter, and if the filter returns true, then it returns the element that it's currently looking at, except it's not quite returning the element, it's using yield return. And that's a special feature in C# that essentially maintains the state of this method, so that the next time it's invoked, when you're going through the enumeration, it will apply the filter on the next element in the enumerable. So it retains the state across invocations, which is fundamental to being able to do this. So now in my when I'm going through the loop, I can pass my where parameter, or I can invoke the where function, and it takes the enumerable as a parameter, and my filter so only returns elements that are of length 3. And so if I run it, then I get 1, 2 as a result. Next step would be to make that a generic filter. So I can instead of saying it's an enumerable of strings, I can just say it's an enumerable of t's, and then I could work with enumerable of strings or integers or whatever I want to. And so this exactly the same code on the calling side of things. It's just now a generic method, a generic filter, rather than one that only works with strings. The next thing to do would be to make an extension method. So this is a way of assigning or adding a method to an existing class. This is something Kotlin has. I think they probably stole it from C#, but I'm pretty sure that C# stole it from somewhere else, and so maybe they stole it from that place first. I don't know, but it essentially lets you add a method to an existing class. So I can say enumerable.where rather than passing or having the where function and passing enumerable as a parameter. So the code looks a lot nicer. And the way it works in terms of defining an extension method is this special keyword this in front of the type. So now this works with any enumerable of strings, integers, and so on. I can just say enumerable.where. Now this is such a cool thing. You'd think that it would be built into the C# programming language, and of course it is actually built into the C# programming language. The language integrated query has a where that works exactly like the where that I just implemented by hand, except of course it doesn't just have where. It has a whole plethora of different functions that you can use to map, reduce, filter collections. So I'm going, I want to enumerate by, or I only want the elements of length of 3. I want to order by descending by the string itself, and I want to define a new type as a result. So this defines a new anonymous type that has the string and its uppercase version. And if I go print, if I go through each one, it prints out each one. So that's kind of built into the C# programming language. And I said it was called a language integrated query, and this is kind of integrated, but not that integrated. What makes it, I think, worthy of the name language integrated query is what I'm going to show you next. Now look carefully at this code here. You're seeing where order by select. I'm going to show you exactly the same thing. This is what makes it the language integrated query. This is valid C#, and it's the same thing, but it's a kind of more fluent syntax. So I'm saying, from S in the enumerable where the s.length is 3, order by, descending, and so on. So this is doing exactly the same thing as the code before, but in a more fluent way. And personally, I go backwards and forwards. Sometimes I'll write it like this. Sometimes I'll write it as a chaining of methods. But it is a nice thing to be able to do. It makes for a much clearer syntax. But it is syntactic sugar. It's translating this into the chaining of methods that you saw a moment ago. You can go a lot further. For example, I can go through each string in the enumerable, and then every character in each string, and see if it's a val. So you can do really wild and wonderful things with this. You can do joins. You can do all sorts. This is good. This is nice. What makes it even more powerful, though, is the fact that it, as well as working with the chaining of the methods, what it can also do, LINQ can also do, is generate an expression tree. So this is a IQueryable rather than IEnumerable. So I've got a connection to SQLite here, and I've got a table, and I'm going through each table, each record in the table, and I'm filtering it for duration length. And what this does, because it's generating an abstract syntax tree rather than a chaining of methods, is that the implementer, this query provider, can take that abstract syntax tree and generate SQL code. So it's no longer generating code, no longer generating C# or .NET intermediate language, it's generating an abstract syntax tree that can be queried. You can walk through it and do whatever you want to. So it generates a syntax tree from this, and the syntax tree can be queried by the query provider and generate SQL. So there's the SQL code that was being generated. And here it's going a lot further. You know, it's skipping and taking. You can do all kinds of stuff. It's pretty powerful stuff. So there's LINQ to SQL, as you saw there, but you can also use LINQ to query JSON, language integrated query to query JSON, or to in Google's cloud, or in Twitter, or in XML, or, and this is one I hope never to have to use in real life, SAP, of all things. So it's a powerful feature that can be used to query in a fluent way all kinds of different data sources. The final thing that I love about C# is async and await. So if you look at every programming language, so this is Apple's documentation, it says, or sorry, every programming framework, Apple's documentation, it says, avoid synchronous network calls on the main thread. And if you look at Microsoft's technology, it says exactly the same thing. And if you look at Android, it says exactly the same thing. This is a common thing. No matter what programming language or what environment you're in, there is one cardinal rule. Do not block the UI thread, because that will make for a glitchy experience from the user. So no I/O on the UI thread, no intensive CPU on the UI thread. Everything goes off into background threads. Now, the old way of doing things, the kind of traditional way of doing things, would be to pass a callback. So let's say, imagine I was on the UI thread here, and I want to read from a file. So I'd pass a callback, and I'd say, start reading this, okay, but don't block me. And then eventually, when we have the results of the reading, then the callback gets invoked. Now, there's a nicer way of doing things in C# called tasks. So a task lets you do essentially the same kind of thing, but I can continue with once the read is finished, I can say continue with, and then it prints out the results. And so this is a lambda. It takes as a input the number of bytes that was read, and it prints it out. So this is a little bit cleaner, but is it really cleaner? Because once you start chaining these together, you end up with this kind of indented code. It's a pain in the butt to deal with, and you see this all over the place in programming languages. So the C# way of doing things is more syntactic sugar, but this syntactic sugar tastes delicious. I can mark this method as async, and then when I invoke a method that returns a task, so here I'm opening a file, I can say await. And what that does is essentially what you saw before. It takes all this code, packages it up, and does a continue with, but it does it seamlessly behind the scenes for me. And the same here. It takes this code, following code, and invokes it once the task is completed. But it deals with exceptions, for example. So essentially you have asynchronous code that looks imperative. So it makes code much more readable, much easier to implement. You write imperative code, and the compiler behind the scenes translates the code. And that, for me, this is really what compilers are for. They're for making difficult things easy. This isn't easy. This is really hard stuff. What happens with exceptions? When these are running, you've got continues with continues. And it is hard stuff, and actually behind the scenes, the compiler will generate an abstract syntax tree, so an abstract state machine to deal with it. So if you look at the code that's generated, it is horrendously complicated, and that's exactly how it should be. The generated code should be complicated, but the code that you write should be very, very readable. And this isn't available, as far as I know, in other programming languages yet. It is there actually in TypeScript, which is, interestingly enough, also a child of Anders Hejlsberg, the guy behind C#. And I'm sure this will come to other programming languages because it makes life so much easier. So those were so just to finish on tasks, you can do things like WhenAll and WhenAny, so you can wait for these tasks to happen. So this is actually from a real project I'm working on. I have some I'm invoking some code to speak some text, and this I think goes off to the network and uses Amazon's Poly service to render human-sounding speech. And I'm also getting some recommendations from a recommendation service. These are 2 network tasks, and I can run them in parallel. I can say, task.WhenAll. When all of these are run, then I want to do something. And I can equivalently say WhenAny, so that I return as soon as one of them is completed. If I want to do things, or I want to invoke lots of things at the same time, and then be told when any of them have finished. So those were my 3 things in C#, and I hope you can see why they make programming in C# so nice. What about Xamarin? So this title of this talk is iOS and Android and C# and Xamarin. These are a few of my favorite things. So I'm going to share 3 things that I like about, or that make programming in Xamarin so much fun in C#. So just to take a step back, there is a guy called Miguel de Casa, who was largely responsible for GNOME. And in his spare time, he started writing his own C# compiler. This is back in 2001. And that went to Novell. So Mono, the environment he created, went to Novell. And unfortunately, Novell, well, fortunately actually, in many ways, Novell fired them all, but managed to get all the people that were working on Mono, but the Novell team managed to get the rights to continue working in Mono, and they went and created a Xamarin, and which was a way based on the Mono technology of programming on iOS and Android using C#. Now this was really cool, but as an independent developer such as myself, the fact that it cost $1,000 per developer per platform made it was prohibitively expensive. I actually had I paid for iOS Xamarin for iOS, and I got in early at $250 a year instead of $1,000 a year, and I used that to program. But it was still kind of I was conflicted because it was so cool to be able to program in C# and on iOS and Android, but the fact it cost so much, really hurt. And then something great happened, which was that Microsoft bought Xamarin in 2016 and made the technology available for free. Now there's a free version of Microsoft's Visual Studio, which is available for independent developers, I think up to teams of 5 people, for free, and it's pretty much got everything you want in it. I at some of my clients, I programming using Visual Studio Enterprise, but I rarely make use of many features that they have. There are some, but mostly you're fine with the free community version. So right now you can go and download Visual Studio and program for free, and program on iOS and Android for free. So what I want to do first is just share a little bit about how to program, how you use them on iOS and Android. So this is using Microsoft Visual Studio, and I'm saying I want to create myself a new application, a new iOS application, and I can choose all the different kinds of applications, so Scene Kit, Sprite Kit, Master View, so you can create them all using C#. There's pretty much nothing you can't do using Xamarin that you can't do using Swift. Now, I just want to take a step back. How is this even possible? Apple are notorious for strict control of iOS, and so how did they allow Xamarin to work? The way that they allow it to work is that when you program on iOS using Xamarin, you're not using the .NET virtual machine. What's actually generated is native machine code. So there's a backend, an LLVM backend for Mono that's generating assembly language essentially. So there's nothing to stop. There's no way to tell when the program is running that it's not wasn't written in Swift or Objective-C. It's generating or using LLVM just like those environments. So that's how it's possible. There's no interpreted code. There's no virtual machine running. Everything's running natively. So I enjoy running, and I use an app called Runkeeper. And I also like listening to podcasts, so I use Pocket Casts. And when I go running, I take my watch, but I also have to take my phone because there's no way of transferring those podcasts that run on my phone onto my watch. Even though the Apple Watch is capable of playing music to my Bluetooth headset, I could, in theory, just run with using my watch, but I can't using this setup. Runkeeper runs on the watch, but not Pocket Casts. So I created myself an app that lets me listen to my podcasts on my watch. So this isn't C#, this is Xcode and this is Swift code. And this is the code that is generated when I say I want to create myself a project that has an extension in it that can be used to receive items from other apps. An action extension. So the way I wanted to make my app work, I called it Watchcasts, was I'd be in Pocket Casts and I would kind of share a podcast to my app, and in order to do that I need to receive it. So this is Swift code, and this is the sample code that Apple provide. So it goes through the extension, the extension context, the input items, and then it looks to see is there an attachment, and is there one that's a string or sorry, an image, and if there is, then it loads it. So that's the Swift code, and this is the equivalent code in C# using Visual Studio. So I'm running Visual Studio on my Mac here, and we've got an action extension because you can do pretty much everything you can do on Swift you can do in C#. And this is how I filter the items that are passed in. So I compare the code. So I'm using LINQ, going through each input items where there's an attachment. Then I look to see, well, do I have a URL in this case because I want the URL to the podcast, and then I load the item asynchronously. So if there aren't any, I return, and then I await the results. So none of those callbacks, that you see in Swift, it's inline code. So I'm not going to go into much more detail, but the fundamental point is that you can write C# code for iOS using the native frameworks, but they've been translated in a way that makes sense for C#, and this makes it in many ways, very often, cleaner code than using other programming languages. So this is this gives you a flavor. So I have my main app, I have my extension, I have my watch app and watch app extension, and I have code shared between the app that runs on the phone and the app that runs on the watch. So that's kind of just to give you a flavor of how it works. I'm programming in C# using the .NET framework, but I'm also using the native frameworks that come with iOS, for programming on iOS. Now, the Friday before I gave this presentation, a competing podcast app to Pocket Casts, which I know a lot of people like, called Overcast, release something that does exactly what I want to do. Was that what I was doing there? So I'm not going to release this. I imagine the Pocket Casts are going to come out with their own. I hope Pocket Casts are going to come out with their own equivalent soon, so you can listen to your podcasts on your watch. So it was still fun to experiment with it. Just to kind of hammer home the point, you can do everything on using C# and Xamarin that you can do using Swift or Objective-C. So here I'm accessing HealthKit to fetch information from HealthKit. So the HealthKit framework, using the asynchronous or async await, I can get all the different pieces of information I want from HealthKit, and then wait for them all to complete and return them. So it's really cool. There's pretty much nothing you can't do on iOS using C# and Xamarin. On Android using programming on Windows, or on the Mac using Visual Studio. So what about on Android? It's a very similar story. In fact, very, very similar. You can create Android Wear apps, you can create OpenGL apps, you can create normal Android apps, everything. And the really cool thing is that you can share a lot of your code across iOS and Android. All the non-UI stuff you can share. So here's a C#, the C# app, and you're using activities, you're using all the standard stuff, content providers, everything you'd expect, you're using. Nice thing is you can use generic methods, find view by ID, or a button to return a button, rather than having to cast. So there are some nice things there. Although with Kotlin, life has become much nicer for Android developers. Now there was a third way of doing things. So what I've shown you so far are native iOS and native Android apps. What you can also do is use something called Xamarin Forms. Xamarin Forms let you create a UI once and build an app that runs on iOS, Android, and Windows, and soon Mac as well. So how can you create the UI once? That sounds awfully like Java Swing, which made for a UI that looked terrible everywhere. And that's not what this is. This is using the native UI components to generate the app. So I have, as I mentioned before, I've worked for Evernote for a while, and one of the things about Evernote is that everybody wants something different from it. Everybody's use case seems to be unique, and so the way I use it is I have 2 Evernote notebooks and several hundred tags, and I file things in my unfiled notebook, and then I tag them and move them to my personal notebook. So I've created myself an iOS application that lets me file my notes very quickly, because this is a pain. Every month I have to go through my inbox and file them, essentially by tagging them and then moving them. So I created myself an app that lets me do this really quickly on my phone. And because I use Xamarin Forms, I was able to do it using on Android, or this app runs on Android and iOS and Windows, and potentially the Mac as well. So this is running on iOS, and we have a table view at the top here. We have a PDF. These are all native components. The way the UI is defined is using something called the XAML. XAML is pronounced as XAML. And so I defined, in this case here, my list view, which is a set of notes. So I have a binding context that says this is the class that sits behind this view. It's the view model. So I'm binding my list of notes to the notes property on the view model. In this case here, it's main. So this is essentially the view model way of doing things. Model view model. So this is my view. It's defined using XAML, and then I have my view model behind the scenes that it's bound to. So this is my observable collection of notes that is bound to that list view. And the nice thing is that this view model knows nothing at all about the view that's viewing it, that's bound to it. I can test this view model independently of the view. So there's no UI code here at all. I'm just defining my set of views. I'm defining properties that are exposed to the view. And then so we have the view, which is the XAML. We have the view model here, and then we have the model. So this is the set of notes that is being exposed in that collection. So that view model that you saw, so that list view that you saw here, there is no list view type in iOS. So how does that get translated? The way that gets translated is using something called a renderer. So for every UI component that you can use in Xamarin Forms, there's a renderer that renders it for a particular platform. So that we have a list view render that renders it as a UI table view. So that's how things work. There's a renderer that renders each UI component for each platform, and you can go in and view this because Xamarin Forms is open source. So I'm on GitHub here, and I can go and see how each one is done. So you're not obliged to use Xamarin Forms, but if you've got a simple application that maybe a business application or an application that doesn't need a really fancy user interface, Xamarin Forms is often a really easy way of building an application that runs on multiple platforms. So there are cases where you might want to modify the renderer. So as I showed you before, there was a PDF that was being displayed and I was using a web view and to host the PDF. And on iOS, I wasn't able to pinch and zoom that web view. So what I was able to do is create my own zoomable web view renderer derived from the Xamarin Forms renderer, web view renderer, and I modified the native the native UI control that was being used to allow for scrolling and pinch and zoom. So that's so you can create your own renderers to customize the behavior, and there are other ways of doing that. So the downside to Xamarin Forms is that you are limited to the set of components that are that are in common across all the platforms. So there is a limited set, but more recently, Xamarin have allowed you to embed native controls in a Xamarin form. So you could embed an Android native component in a Xamarin form. Now that obviously wouldn't do anything on iOS, but it does let you make use of native components, even the ones that are not supported or not built into Xamarin Forms. There are loads and loads and loads of different plugins to do things in a cross-platform way. So, for example, to detect whether you have a network connection, you can install this plugin into your Xamarin Forms app and use it on iOS and Android and Windows. And there are loads of these, and I make extensive use of these plugins to do things in a cross-platform way. So there are two different ways of doing things using Xamarin. You can either create completely native applications where you might share code across by sharing business logic, but you can also use Xamarin Forms, and whether the choice of which one to use really depends on what kind of application you want to create. So going forwards, what's really nice about iOS or about Xamarin is that it's not just Microsoft. There's also Red Hat. There's also JetBrains, the guys behind Kotlin or AppCoder. They got a very popular plugin that I make massive use of called Resharper that plugs into Visual Studio. So .NET is open source, and obviously the underlying platforms, iOS and Android, are constantly updated, and as quick as they're updated, there are new versions of Xamarin with native Xamarin bindings, C# bindings to these new native features. So that's really nice. They're really responsive in terms of releasing updates to let you take advantage of new features that are released. So if you want to play around with this, you can download Xamarin Studio, although that's been kind of essentially, I think it's being deprecated in favor of Visual Studio for Mac, which is available now. And obviously there's Visual Studio for Windows as well. There are other platforms or ways of developing in .NET. So C#, for C#, there's something called Continuous, which runs on iOS. So on your iPhone or on your iPad, you can use Continuous to build apps using C#, or at least to program in C#, and F#, another programming language supported by .NET Framework. So this has been my presentation. I hope you've enjoyed it. Feel free to contact me at damien@mears.com or at damienmears on Twitter. Also, I am available. I'm an independent consultant, so feel free to contact me if you need someone who's been programming in Xamarin for quite a long time and knows their way around it. Thanks.